Before we ever get into the amines chapter, we saw some ways to make amines, and we're just going to review those quickly. The first one that's shown here is preparing an amine from an alkyl halide. So we take an alkyl halide and then we can treat that with sodium cyanide. And so cyanide is going to be the nucleophile here. I'll draw the whole Lewis structure of the cyanide ion. We have the negative charge on the carbon. And so that's going to be able to displace our halide via an SN2 reaction. So of course the limitations of SN2 apply. Then we have our nitrile, okay, and we can reduce the nitrile using lithium aluminum hydride in excess, followed by water. Notice that here it's water and not H3O plus, and the reason why it couldn't be H3O plus is because if it was, you would end up with the ammonium salt, okay, so you don't want that. So we just use water in the second step to donate the proton. And we notice that when we do this process that we expand the carbon skeleton by 1 carbon. And you can see that new carbon is here. So we started out with 1, 2, 3, 4, 5. And now, since we use cyanide, which has a carbon in it, now we have 1, 2, 3, 4, 5, 6 carbons in our new amine. The next method for preparing an amine is generating one from a carboxylic acid. So the way we do that is we take our carboxylic acid, we treat it with thionyl chloride, which makes the acid chloride, and then we treat that with excess ammonia, and that displaces the chloride, and we end up with a primary amide like you see here. And then hopefully you remember this reaction from chapter 20 that we can reduce that primary amide. We just excise this carbonyl from the molecule by using excess lithium aluminum hydride followed by water, of course, and not H3O plus. And you notice that in this case, we're starting out with 1, 2, 3, 4, 5, 6 carbons, and we end up with 1, 2, 3, 4, 6 carbons. And so the carbon skeleton is unchanged. So taking a carboxylic acid, making an acid chloride, then making the primary amide with ammonia, and then you can reduce that with excess lithium aluminum hydride and then follow that up with water. Notice that there's no mechanism provided for this reaction in the textbook, the reduction of the amide with lithium aluminum hydride. The next one is making anilines, or making an aniline from benzene, and you probably remember this guy here. This is aniline. Okay, you could call it aminobenzene, but the common name is aniline. And it says here nitration of a benzene ring followed by reduction provides aniline or aniline derivative. So the first step is going to be our nitration. And for that we make the nitronium ion by reacting nitric acid and sulfuric acid together. So you guys would remember the nitronium ion, which is a super powerful electrophile. I'm not going to get into the electrophilic aromatic substitution, but we do an electrophilic aromatic substitution. We end up making a nitrobenzene. So this is nitrobenzene, or you could make some derivative of nitrobenzene, and then we can reduce it. So you see there's a whole holy host of different ways to reduce it. The nitro down to the amine. Okay, so one way is just using hydrogen gas and palladium, platinum, or nickel. Okay, there's nothing wrong with that. And we can also do metal reductions where we either use iron or zinc or tin in aqueous acid followed by treatment with sodium hydroxide. Now, if you're wondering why do you need sodium hydroxide in the second step, it's because after the first step, okay, since you're in aqueous acid, you wouldn't get aniline. What you would end up with would be an anilinium ion, which would be this here, NH3 plus. NH3 plus, okay? And so you need the sodium hydroxide to deprotonate and give you the free base. So I'm just going to delete the anilinium ion. But anyhow, so that's why we have the sodium hydroxide in the second step. Now, in the textbook, it goes into some more detail about this reagent, okay? The tin, so this would be tin 2 chloride. Tin 2 chloride. And if you're wondering, why would they put tin and tin 2 chloride on the same slide if they both do the same thing? Well, the thing about the tin 2 chloride is that it's a mild reducing agent. So we'll just put here mild. And so they show you an example in the textbook where the tin 2 chloride in aqueous acid will reduce the nitro down to an amine. but it doesn't reduce something like a carbonyl of an aldehyde at the same time, okay, again, because it's a mild reducing agent. Whereas if you treated the molecule with hydrogen gas, that would just reduce everything. So it's just a more mild method of nitro reduction down to your amine. Okay, draw the structure of an alkyl halide or a carboxylic acid, so we'll do both for each one, that might serve as a precursor in the preparation of each of the following. Okay, so if we're going to do alkyl halide chemistry, right, for that we're going to use the sodium cyanide, right? We're going to do the SN2 with the sodium cyanide, and then we're going to reduce that with lithium aluminum hydride. If we're going to go the carboxylic acid route, in that case, in the first step, we're going to use thionyl chloride, and then we're going to use excess ammonia to give the primary amide, and then we're going to reduce it with LAH, and then do our workup with H2O. Okay, so those are our two possibilities. Anyhow, so let's start with the first one. Now remember, when you're using the alkyl halide method, remember that you're adding a carbon, and so the cyanide would provide this carbon and this nitrogen, right? So that means we're going to need 1, 2, 3 carbons in our alkyl halide, and so we're going to use 1, 2, 3, and we'll just make it an iodide. You could make it a bromide, you could make it a chloride, it doesn't matter. So in the first step, we're going to treat it with sodium cyanide. That's going to give us 1, 2, 3, 4 carbons, and then we're going to reduce that in the first step with LAH, second step with H2O, and that is going to give us our amine. Okay, if we go the carboxylic acid route, in that case, there's no changes to the carbon skeleton, rather. And so the carboxylic acid, if you could just permit me to scribble, it's going to be this carboxylic acid, right, which is butyric acid. So we'll start off with butyric acid. So here we go. So butyric acid. Step 1, we're going to treat that with our thionyl chloride. Step 2, we're going to treat it with our excess ammonia. And that's going to give us our primary amide. Then we're going to reduce that with lithium aluminum hydride, followed by water. And that's going to give us our product, just like that. So both perfectly reasonable ways to make this compound. I'm going to move a little faster with B since we've gone over the concepts. Okay, so if we're going to do the alkyl halide method, these two, this carbon and this nitrogen, would come from the cyanide, and so our alkyl halide would have these carbons in it. So we would start with this as our alkyl halide. Okay, I chose bromine. You could put iodide, you could put chloride, but we're going to put benzyl chloride, or benzyl bromide rather, and I'm just going to write down all the steps. So sodium cyanide, followed by lithium aluminum hydride, followed by water. And I'm just going to abbreviate the aromatic ring as pH, and that's going to give us our amine. Okay, if we wanted to do the carboxylic acid method, again, there's no changes in the carbon skeleton. We're doing the carboxylic acid method, so this would be the carboxylic acid we would start with, if you could just permit me to scribble over everything there. So again, I'm going to abbreviate the aromatic ring as pH, just to simplify my life a little bit. So there's our starting carboxylic acid and the 4 steps. First one, thionyl chloride. Step 2, excess ammonia. If you write these down enough, you're going to remember them, won't you? Right? Then lithium aluminum hydride. Repetition is key in organic chemistry. And there you have it. So 1, 2, and there you go. So let's try the next one. For C, if we do the alkyl halide method, this carbon and this nitrogen are going to come from the cyanide. And so our starting material is just going to be cyclohexyl bromide or iodide or chloride, doesn't matter. First step, some sodium cyanide. Second step, throw some lithium aluminum hydride in there to reduce. Then you need to do your proton transfer with water, not H3O+, and that's going to give you this beautiful amine. And if we want to do the carboxylic acid method, remember our carboxylic acid is just going to be this here, so it'd be cyclohexane carboxylic acid. So maybe I'll use a different color pen here. You've really got to do all the practice problems. Okay, so when I'm doing these, you should be pausing the video, and giving it the old college try. So let's practice writing our steps. Thionyl chloride. Step 2, excess ammonia. Step 3, lithium aluminum hydride. Step 4, put some water on it. And hot dog, we have a wiener. There you go.